Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from mechanics, and these two particular questions belongs to paper 9709/43 for the session October-November 24. Let's read question number 1. It says an athlete has mass mkg. The athlete runs along a horizontal road against a constant resistance force of magnitude 24 Newton. The total work done by the athlete in increasing his speed from 5 meter second to 6 meter per second while running a distance of 50 meters is 1541 joule. Find the value of m. So through the question they have suggested us that we will apply the concept of the work energy equation, because look at this, they have written the total work done. They have disclosed that the total work done by the athlete is 1541 joule. That means indirectly they have disclosed that we should apply the concept of the work energy equation. So let us write the work energy equation. Work energy equation is work done by driving force minus work done by resistance force is equal to change in gravitational potential energy plus change in kinetic energy. Well, so let us write what is the work done by driving force. It's already given, it is 1541 joule minus work done by resistance force, and we know work done by resistance force is the product of force into displacement. Force, that means resistance force into displacement. Then change in GPE is actually mgh plus change in kinetic energy is half of mass into v square. V square means difference between the final and initial velocities. Well, so 1541 minus resistance to motion is of 24 Newton is the resistance force. So 24, and displacement traveled by the athlete was 50 meters. So let us multiply by 50. Now mass of the particle is to be obtained and acceleration due to gravity is 10. Then we will find the difference between the heights, initial and final height. Look at this, the athlete is running along a horizontal road. So the difference between the final and initial height is 0, because he started from the same height from the ground and ended also at the same height. So difference between the initial and final height is 0. Then half mass is to be obtained and v square, that means final velocity square minus initial velocity. Let us see what was the final velocity. Final velocity was here 6 meter per second and initial velocity was 5 meter per second. So let us write the final velocity, square of final velocity minus square of initial velocity. Well, let us do simplification. 1541, so 24 into 50 means 1200. If we do subtraction, it is going to be 341 equal to the first quantity is 0. Then 36 minus 25 means 11. So it is 11 m over 2. Or if we make m as subject, m is equal to 341 into 2 over 11. Hence our m is going to be, if we do simplification, I mean division, 11 threes are 33, then 11 ones are 1. So if we multiply by 2, it is going to be 31 to 62. So our answer to the question number 1 is 62. So the mass of the athlete was 62 kg. Let's read question number 2. The next question is, the next question is, yes. Coplanar forces of magnitude 16 Newton, 12 Newton, 24 Newton and 8 Newton act at a point in the directions shown in the diagram. Find the magnitude and direction of the single additional force acting at the same point which will produce equilibrium. Okay, so the system is given over here and we will have to find an extra force which will make the system equilibrium. So before doing anything, we will just complete the diagram. Let us complete the diagram. Let me continue until the, yes, then over here. So we have completed the diagram. Then as we are to find, as the system is not in equilibrium, we will have to find the resultant forces. So first of all, horizontally we will find the resultant force. Horizontal resultant force. Okay, direction is horizontal. Okay, let's see what is the driving force horizontally. First of all, there is 24 Newton. So 24 Newton. Then we will find the negative forces. And not only 24 Newton, then the first this triangle. From here it is plus 20, I mean 12 cos 30 degree. 12 cos, not 30. Look at this. If this portion is 30, this is going to be 60. Okay, so 12 cos 60 degree. 12 cos 60 degree. Whether there is anything in positive direction or not, there is, yes, another triangle. In the another triangle, it is 8 cos 30 degree. 8 cos 30 degree. These are the magnitude of the forces in positive direction. Now for negative direction, this is the negative direction. So for this triangle, the magnitude is going to be 16 cos 30, sorry, minus 16 cos 30, minus 16 cos 30 degree, 16 cos 30 degree. So this is the resultant force in horizontal direction or in x-axis, along x-axis, or 24 plus cos 60 is half, so 12 over half is actually 6, plus 8 cos 30 minus 16 cos 30 means 8 cos 30, negative 8 cos 30, and cos 30 is actually 8 cos 30. Cos 30 means square root over 3 over 2. So finally, our resultant force in horizontal direction is going to be 24 plus 6, 30. 30 minus 4, so 30 minus 4 square root over 3. This is the resultant force along x-axis. Okay, square root over 3. Now vertical resultant force. Okay, that means upward or downward force. Vertical resultant force, we may change the ink. Vertical resultant force, vertical resultant force, resultant force. Okay, vertical direction. So let us see what are the force acting upward. Upward forces are, first one is 12 sine 60. 12 sine 60 degree. Then there is no more force acting upward. Then for downward, this is the triangle and this is the another triangle. So we can write here minus. Okay, these are the downward forces. Minus 8 sine 30 degrees, sine 30 degree, again minus, I mean downward force, 16 sine 30 degrees, 16 sine 30 degrees, sine 30 degree, 30 degree. Now we know that sine 60 is equal to square root over 3 over 2. Okay, so square 12 into square root over 3 over 2 minus 8 and 16 means 24. 24 sine 30 is half. So 24 over half. I mean 24 over 2. So the first one is 2 6 is 6 square root over 3 minus, if we divide 24 it is going to be 12. So 6 square root over 3 cannot be equal to 12. That means it is actually negative force. Okay. So how can we write the magnitude of the force is negative? That means downward force is more. Minus 12 plus 6 square root over 3 is the force acting downward. Well, now let's go back to the question. The question told us to find the magnitude and direction. So first of all we'll find the magnitude. Okay, so let us write the magnitude using a different ink. Well, magnitude of resultant force. Magnitude of resultant force. I think before that I can show this through figure. Okay, let me draw a figure with red ink. Yes, this is horizontal x, positive x, and this is positive y. Okay, positive y, origin is over here. Let us see the quadrant where the magnitude falls in. Look, our x direction, it is positive. X is positive, this one. Resultant force along x axis is this one, which is positive. But our vertical force is negative. Here it is negative force. So x is positive, y is negative. What is the quadrant? The quadrant force, our resultant force is over here. Okay, and this will be our angle. So resultant force, let us find the magnitude of the magnitude. Okay, magnitude magnitude of resultant force or total resultant force. Let us write total resultant force. Total resultant force. Total resultant force. Resultant force. How can we find the magnitude of this force? You know, it is if we draw a triangle over here, if we want to find the magnitude that means hypotenuse. Okay, so we will write here hypotenuse is equal to square root over horizontal distance square, I mean horizontal square component square plus vertical component square. So what was the horizontal and vertical component? It was horizontal component was, we have written here, it is 30 minus 4 root over 3 and 12 plus 6 root over 3. So 30 minus 4 square root over 3. 4 square root over 3 is the horizontal resultant force. 4 square root over 3, and vertical one is 12 minus 6 square root over 3. 12 minus 6 square root over 3. This is the vertical component. So we are finding this is the hypotenuse, means resultant force is x component square 30 minus, let us use the same ink, 30 minus 4 square root over 3 squared plus vertical component square 12 minus 6 square root over 3 whole squared. Okay, it will be extended equal to, let us use our calculator. If we use our calculator, it is going to be square root over 30 minus Newton equal to 23.1 Newton. 23.1 Newton is the resultant force, magnitude of the resultant force. Okay, then if we extend the triangle, look at this, our question actually asked us to find, look at this, the question told to find the magnitude and direction of the single additional force acting at the same point, which will produce equilibrium. Okay, so we'll have to make the system equilibrium. So if we want to make it equilibrium, look at this, the resultant force is acting over here, so our, there should be opposite force to be given to make it equilibrium. So what is the our opposite force? Opposite force will be in the second quadrant, because resultant force falls in the fourth quadrant. So in the second quadrant there will be our additional force to make it equilibrium. I think you got my points. They have told us to find the extra force which will cause equilibrium. So to make the resultant force falls on the fourth quadrant, then if we want to make it equilibrium, we will have to have extra or additional force on the second quadrant. Okay, we have got the resultant force. Now direction, I mean angle should also be obtained. So we can write here, let us write. Now we will find the angle, the result angle where the additional force should be applied. So angle is here. Okay, we can write tan theta. Suppose this is our theta. Okay, it is going to be our theta. So tan theta is equal to tan theta equal to, you know, vertical force over horizontal force. Vertical force was 12 minus 6 square root over 3, and horizontal force was 30 minus 4 square root over 3. 30 minus 4 square root over 3. 30 minus 4 square root over 3. Hence our theta is going to be, tan inverse of 12 minus 6 square root over 3, 6 square root over 3 over 30 minus 4 square root over 3. Well, okay, then our theta is going to be equal to, let us calculate, is tan inverse of 12 minus 4 root over 3. Tan theta is equal to tan inverse of 9 degree is the angle, 3.99 degree. So we have not forgotten that the question has told us to write the additional force required for the system to be equilibrium. So we will write here, hence the additional force is equal, magnitude is equal to magnitude of, let us write magnitude of magnitude of additional force, magnitude of force is equal to, already we have obtained, how much did we get? Magnitude of force was 23.1 Newton and angle is 3.99 degree. Okay, so force is 23.1 Newton. 1 Newton. Direction is equal to, now direction is equal to direction is how much? 3.99 degree, 3.99 degree above. Where is our resultant force? So let us see the figure. Look at this not resultant force, extra force should be over here. Okay, so this is above negative side, negative x-axis. Okay, so we will just mention this. Direction is 3.99 degree above negative x-axis, negative x-axis. So that is what the answer we should show. So what did we find? First of all, we have found the resultant force. Then the force should be applied in opposition so that the system is in equilibrium. And we, after calculation, we have found that the resultant force is lying on the fourth quadrant. So additional force should be inserted or applied in the second quadrant to make the system equilibrium. Thus, we have got that our final answer is 23.1 Newton, 23.1 Newton, and it is 3.99 degree above negative x axis. Okay, these are the magnitude and direction of the additional single force which will make the system equilibrium. I think you have understood how to solve such question. Then let's move on to the first part of the solution. This was the answer to question number 1, and this is the answer to the question number 2. So what did we do? Um, if I recapitulate since the beginning, first we have found the horizontal resultant force, then we have got a vertical resultant force. After that we have got the magnitude, and magnitude, it's the sum of the square root of the sum of the horizontal and vertical forces. After that we have found the angle where it is lying. We should know that how much was the distance of the, measure of the angle. And for that we have applied the tan theta. If we use tan theta, because we do have the component of vertical as well as horizontal component, so tan theta serves better. After that we have written the magnitude of force, additional force, and direction of the force is 3.99 degree above negative x axis. So thank you all for being with me. Fi amanillah.